Okay, so in this example, we're given the substitution, okay, to be x equals sine theta, all right? So this time the substitution involves a trigonometrical function, okay, and it'll make it easier to actually integrate this, okay? What's different as well is that now we've got a different variable. So in the previous examples, we've had u equals 2 in terms of x, and then we could substitute in, yeah? In this case, different setup because they're saying what x is equal to, and we've got it in terms of theta. Okay, so a new variable would be theta. So when we substitute in, the x squared is going to be easy, isn't it? Because you just square this here, so you get sine squared. And then I just got to determine what dx is. So I'm going to differentiate now, because this x, in terms of theta, it'll be dx then by d theta. Okay, because you differentiate this function here, so x with respect to theta, dx by d theta. So differentiate sine, of course you get cos theta. And then ask yourself, well, what do I want? Okay, well I want to replace dx, so I want to know what dx is equal to. So when you see this here, you can easily work out what dx is equal to, yeah? You just take the d theta up. So dx is equal to cos theta, taking the d theta up and times, okay? And there you have it, right? That's what dx is. Now, the other thing you've got to do then, of course, is the limits. Remember the limits are in terms of x. We have to change that now to the limits in terms of theta, okay? Because remember, we're replacing everything in terms of theta, so we've got to change these limits as well, right? So that will be x equals 0, yeah? And that will be x equals to 1 over root 2. So let's figure out what theta is. So you go back to your substitution to do that, okay? So in the case when x is 0, right, well, put it in there, you have 0 equals to sine theta, okay? And then you just got to work out what theta is from there. So you might know what that is straight away, or you could take the sine over and do sine to the minus 1, okay, of 0 will equal to theta. And of course that just comes out to be 0, okay. Do the same then with the when x is 1 over root 2, okay. So 1 over root 2 is equal to sine theta, okay. So that implies then that sine to the minus 1, so we take the sine over to the sine to the minus 1 of that. Okay, we take the sine over, you're left with theta, it'll equal theta. And do that on your calculator, and it'll come out to be pi over 4. Now I say pi over 4, because remember, it's got to be in radian mode. Okay, so with my calculator here, I'm in degree mode here, so I need to make sure I change that to shift, setup, angle unit to, and press radian there. Okay, and then do shift sine, so 1 over root 2, and it comes out as quarter pi, yeah, or pi by 4, pi divided by 4. It's got to be in radian mode when you've got calculus, okay, when you're integrating or differentiating, otherwise it won't work, okay, the results are different when you use degrees. So there you go, so our integral becomes, now, so limits now, new limits are 0 and pi by 4, okay. The root then, we've got here, because it's still a square root, don't forget, but it'll be 1 minus, now in this case it'll be x, so x squared rather will be sine squared theta, okay, and then your dx will become cos theta d theta, okay. Now you're looking at this and hopefully it'll sort of bring back memories from last year, okay, and we've been using it this year, what 1 minus sine squared is. Well, remember of course sine squared theta plus cos squared theta is equal to 1. So 1 minus sine squared is simply cos squared, yeah? You take the sine squared over. So that will be the square root of cos squared theta, cos theta d theta. So square root cos squared, that just comes out to be cos theta, okay? Because you're squaring it and you're square rooting it, so it undoes it, okay? It just takes you back to cos theta, so pointless squaring it, I guess, isn't it? But if you square it and then square root, you're back to where you start with cos theta. And of course, you've got that cos theta here, d theta. Okay, so this becomes then well, cos theta times cos theta is cos squared theta d theta. All right, and we saw then in the previous video how to integrate when we've got cos squared theta. Okay, so remember, it always goes back to your double angle rules. Okay, so with the double angle rules, let's just remind ourselves, if we've got cos 2a, that will equal to 2 cos squared a, okay, minus 1. All right. So in this case then, well, of course we're going to use theta, aren't we? So I can change that to theta. But you just take the 1 over, so cos 2 theta plus 1 is 2 cos squared theta. And then divide by 2. So it'll be cos 2 theta divided by 2 plus 1 divided by 2 is equal to cos squared theta. So instead of integrating cos squared theta, I can integrate this, okay? So the integral between 0 and pi by 4 of this here, okay? And what you can do, of course, is appreciate that this would equal to a half cos 2 theta plus 1, okay, as we saw in the last video. Okay, you can factorize out a half. So when I replace cos squared theta with this, I can put the half on the outside, okay, and cos 2 theta plus 1 on the inside there, okay. Integrate it, well, when you integrate cos 2 theta, you just get sine 2 theta over 2, okay, and then 1 then becomes theta, okay, because it's just a constant, so it integrates to become the variable theta between pi by 4 and 0. Plug it in, okay, so then you've got sine 2 pi by 4 over 2 plus pi by 4. Take away then, what have we got there? Half sine 2 times 0 over 2 plus 0. Okay, so you put pi by 4 in and you put 0 in. So when I work this out here, well, if you work them out separately, that would just come out to be a half plus pi by 4. That just becomes 0. So there's your answer, and to 4 decimal places, 0.6427.